Okay. So as I said, welcome. We're delighted to have you with us. We are going to begin doing some mathematics together to introduce you to the current primary feature on the NRICH website. Before we do some maths, I'd like to give Trinity College in Cambridge a special mention for funding this webinar for us and the series of webinars, which means that they're free to you as participants. So thank you to Trinity College. We'll be asking you at various points to participate using the chat facility. So please do feel free to use that either to ask questions when you wish, but particularly to join in the mathematics when invited. Do make sure, please, that your name is displaying in a way that you'd like it to, and obviously change it if not. The recording of today's session will go on the NRICH website, and we'll give you the link to where you'll be able to find that towards the end. Okay, so I think it's time to do some mathematics. Charlie, Ems, I'm hoping you would butt in if I've missed out any little housekeeping. Charlie, give me a nod if we're okay to do some maths.
We're okay.
Great, thank you. So let's begin. I'm going to share my screen again. This time I'm going to be sharing the Enrich website. Here we go, enrich.maths.org. And because we're joining today from the point of view of primary practitioners, I'm going to click on the primary teachers button at the top there. And this afternoon, we're going to focus on the activities which are in our current feature. So I'm going to click the pictures of fish on the right-hand side. So Charlie and I, sorry.
Liz, could you zoom in a little bit? Of
course, yeah, good idea.
Small.
Yeah. Is that better?
That's good.
Okay, thank you. So Charlie and I are going to have some conversations around the purpose of the feature, the tasks themselves. We'll be talking a bit about the mathematics, but also a bit about the pedagogy. And as I said, we'll be welcoming your input as well. So Charlie, here we go. Here's the current primary feature. As you can see, it's about digging deeply into number. So we are offering activities in this feature, which we hope will really encourage your children to get their teeth stuck into some number tasks and some calculation tasks, so that they'll really develop their understanding. They'll have chances to think about the structure of number, to do some reasoning, and in particular some generalizing as well. Charlie, do you have any particular questions, having heard that little interaction? Anything you'd like to ask about particularly?
No, but perhaps I should just clarify that you are the person responsible for the primary problems in Enrich, and though I've heard you talk about them, I don't have very much knowledge, so many of my questions this afternoon are going to be come up because I haven't been working alongside you throughout the process of creating this. Okay.
Okay, brilliant. So, so as part of the feature, so by feature, I mean a collection of tasks and maybe an article all around a particular theme. So as part of this particular feature, we've got an article which goes into more detail about going deeper in number, and it draws on work that we've done with colleagues in Tower Hamlets. I'm not going to say very much about the article because I'd really love you to go away and have a read of it afterwards, because it brings together the themes we'll be talking about very nicely. Instead, what we're going to spend the time doing here and now is having a look at a few of the tasks to give you a flavour of what they're about. Charlie, we're going to start with this one here, which is called Robot Monsters. So I'm going to click on it. Incidentally, you can see here the recommended age range that we might suggest. The challenge level is about how difficult the problem is to solve, in the sense of how sophisticated the problem solving skills you might need. A 1-star problem, which as you see is this one, we'd expect to be really accessible for the majority of children to get a good way through this task, as opposed to a few of our tasks which are 3-star, which require much more sophisticated problem solving skills. Anyway, enough of me talking about that. Let's have a go at the actual task. I'm scrolling through quickly because really I'd like you to have a look at the interactivity we've got here, because we can use this to chat about the task. So Charly, Robot Monsters, as the name suggests, is about us creating some robot monsters. You can see on the screen that we've got some head parts. I've got 3 different heads, and each one is a particular height. So 3 centimeters, 6 centimeters, 4 centimeters. We've got some body parts, 3 body parts. Again, their heights are written on. And we've got 3 leg parts. And what we're going to be doing is we're going to be creating some robot monsters which have got a head, a body, and some legs. So, okay, let's have a go. Charly, how might we go about creating the shortest robot monster, do you reckon? Okay,
and I can see also from just above the interactivity that you have printouts. So some teachers might want to do this with their students with cards.
Yeah, absolutely.
But, okay, so can I suggest that, okay, so the shortest leg are those pink ones.
Indeed, they're 6 centimeters, yeah.
So if we put them at the bottom on the left,
yeah,
I'd be tempted to then line all the legs together at the bottom. So the middle one with 7 centimeters nearby, and then the one with 8 centimeters to the right.
Okay.
And then organize the bodies in a similar way. So the shortest body seems to be the 5 centimeters one.
Right.
Go on the far left.
So that's going to go with the 6 centimeter legs.
And then the tallest body seems to be 8 centimeters. That could go on the far right.
Yep.
And then the other body could go in the middle.
Yep. Okay. And why are you doing it like this, Charly? Can you explain a bit? What's your thinking as you're arranging the pieces?
Well, I'm quite curious about the range of monster heights I can get. So the shortest height would be shortest legs, shortest body, shortest head, which we're going to have on the left. And so we put that looks like it reaches 14 centimeters.
Yeah.
And then the tallest is going to be tallest leg, tallest body, tallest head, which seems to reach 22. And then I've got one in between, which seems to reach 18. And
so perhaps I should make a little note of these heights, just so we've got them recorded here. Just bear with me while I do that.
I can't see what questions are going to be coming up, but I can imagine that one question that comes to mind straight away to me is, can I make all the different heights between the shortest and the tallest, and can I sort of move cards around, move heads and bodies, swap them around, and can I make I can see, for example, straight away that if I put the 4 centimeter head on the shortest monster instead of the 3 centimeter head, the total height is going to go up by 1 centimeter.
Interesting. And how do you know that so quickly?
Well, because there's a difference of 1 centimeter between the 2 heads. Oh, and I could have done the same with the legs. So the legs, so yes, oh look, so
okay.
I know straight away that I can go from 14 centimeters to 15 centimeters by either swapping the legs or the head of the middle one with the far left.
Yeah.
But
okay.
I can also,
Let me stop you there a second, Charly. Let me stop you there, because you are doing that thing which we as adults, we as mathematics teachers are doing. You're asking yourself all these wonderful questions, which is exactly what we'd want learners to be doing in the classroom. If they don't have much experience of doing that, then it's going to be up to us as the practitioners to offer those rich questions, and then they will begin to do it for themselves. So you're absolutely right, Charly, that one of the ways that I would have started this task if I was working with young children is by encouraging them to find the shortest and the longest, like we've done, and you've naturally placed the 3 middle pieces left over as well. Some children might do that, some might not. You have asked yourself a question about, okay, so if I know that the shortest is 14 centimeters tall, I know that the tallest is 22 centimeters tall. Can I get those heights in between? And I'd like us to have a little think about that. So on the chat, those of you participating, what's your instinct? Don't think about it too much. Do you think we're going to be able to make all the different heights? So 15, 16, 17, 18, all the way up to 22 centimeters. What's your instinct? Yes or no? Just give us a quick gut feeling. Thank you, David, for being straight in there. No messing around. It's interesting. We're not in agreement. That makes it much more exciting to explore, I think. Okay, so we've got some yeses, some no's. Well, I'm sure you can imagine what my question is going to be. Charlie has talked through how he might go about thinking about a 15 centimeter tall robot. What might we do next? Where would you like to go next? What might you do to explore whether all these different heights in between are possible? Could you have a little think and then post your suggestion on the chat? What could we do to explore? And what might we do next? Thank you very much for your suggestions so far. A couple more coming in. What I love the fact you've got a range of suggestions here. There is one of the beautiful things about this task, I think, is that there are so many different ways you can approach it. Many of you, being, I guess, slightly more experienced problem solvers, have used the word systematic, or you've talked about finding all the possibilities. You've talked about moving the pieces around to see whether you can make all the different numbers starting from one point to the other. One of the ways in which you could use this task with learners is exactly that, to encourage that systematic working. One of the things we have to remember, though, of course, is that my way of working systematically might be very different to your way, but they are both equally as valid as long as they are a watertight system. So don't make sure you listen to your children's ways of working systematically, even if it's a way you wouldn't have chosen yourself. So there are some conjectures about we can't make 21. I wonder whether we should. So Charlie, finding all the possibilities screams out to me that we need to be working systematically so we don't miss any out. We make sure we get all the possible options. If we use these pieces here, you began to do a little bit of reasoning about how I can get 15 because I can tinker, I can tweak these parts that I've already got to increase by 1. I wonder whether we could carry on that train of thought and see where we get. How might we progress? What would you have done next, Charlie?
Well, I know that I can go from 14 to 15 by, for example, swapping, giving the shape on the monster on the left, the robot on the left, legs of 7. And then I could also have gone up by 2 by...
So that would take us to 15, yeah.
Yeah, and then I could then swap the head with the middle one again, and then that takes me to 16. But I can also now, if I want to go up by another 1, is increase the body by 2, but reduce the head by 1. So if I put the yellow body on the left, that's going to make the whole robot 2 taller. But if I return with my smaller head, I now go, I'm up to 17, and then I swap the heads again, and that takes me to 18.
So Charlie, it's interesting because you're doing 2 things at once here, which we hadn't talked about, we hadn't mentioned, we hadn't specified, but again, you're naturally doing it. You're not just thinking about one way of making, in this case, 18. You're at the same time as thinking about, can we make 18? You're also making it in more than one way. So you've challenged yourself. Some students might do that. Some might not initially. That might need to be you as the teacher giving them a little nudge. And you may want to leave that challenge till later as a follow-up. Anyway, I interrupted. Sorry, Charlie.
It's clear to me, for example, that we can make 18 in at least 2 ways, because we could swap the smaller head and the current head, and then which means that the head would be 1 smaller.
Yeah.
But we could put the 8 centimeter legs instead of the 7 centimeter leg. So the legs could be 1 bigger, and the head could be 1 smaller.
1 shorter. Yeah.
And we could do other things like that, I imagine. We could make, I imagine we could, can I? Yeah, okay. And we can carry on now because we're at 18.
So we're at 18, so can we make 19? Post on the chat, how could we make 19? Take a look at what we've got. It's slightly confusing that I've written 14 underneath it. Let me erase that just so that it's not quite so confusing.
You've got the grid, the axis on the left, which gives you
True. Thank you. How could we make 19 now? Offer a suggestion, please. Change heads. That seems to be, I think 4, 7, 8 is the same, isn't it, as changing heads? Thank you. Lots of suggestions to do that. So that's taken us up to 19. 20, what could we do now? So our head is 6 now. So right, change something else. We can't swap heads, at least from what we've got here. Swap bodies. Okay. So if we take out the 7 and put the 8 in instead, that takes us up to 20. This is one way of doing it. 21. What could we do? So we've got the tallest legs. We've got the tallest body. What are we going to do then now? How can we make 21? Got one suggestion come in.
Yeah, the suggestion seems to be put a head which is 2 taller, which takes you too high, but then you make the body 1 shorter.
Make the body 1 shorter. Fantastic. Okay, so that's 21. So we've done it. We have proven that we can make all the possible heights from 14 through to 22 centimeters. We haven't thought properly about but how many different ways we could make each one. But I think you can see that that is something that some students would want to investigate, which you could nudge.
It seems to me, Liz, I don't expect primary age students to know that if you've got 3 possible heads and 3 possible bodies and 3 possible legs, there are 3 times 3 times 3 different combinations. So we know there are 27 different combinations. And so, but the range of heights between 14 and 22 is much less than 27.
Yes.
So there must be many heights that get done in more than one way. So one interesting question for me, and so this is just me talking as an adult, not as a child. So I don't expect the children to know this, but what would be quite interesting is we could have had a bigger difference between the smallest and the tallest head, between the smallest body and the tallest body, smallest and tallest, longest legs, and still possibly get all the heights in between. So, you know, getting students to create their own body parts so that it's still possible to do all the ones in between would be a really nice challenge. And I've got no idea what the answer is to this.
No. I agree, Charlie. Thank you. That's really helpful. Absolutely. Yes, Maria has sort of summarized what you just said. And again, as you rightly point out, Charlie, you wouldn't necessarily expect primary learners to do that, to come up with that themselves. But yes, what a nice challenge for them to try and recreate their version of what we've done here. I hope that's given you a flavour for this robot monsters problem. Before we leave this particular task, I'd just like to very briefly draw your attention to the teacher's resources of the task. We have teacher's resources for all our tasks on the Enrich site, which offer you, oh, look, now, hang on a second. Sorry, this is me. I need to clear all my writing. Is that going to work if I do that? Clear all drawings? Yes, good. Hopefully those scribbles have gone now. Sorry, I was saying the teacher's resources offer you some suggestions about how you might use the task in the classroom, and they, importantly, they give you a summary of the mathematics that you are introducing children to or developing as you use this task. If I just scroll down, Charlie mentioned as well the resources you could print out, and there's also a link here in the teacher's resources, and there are some follow-up tasks should you wish to do a different challenge as opposed to something that like Charlie suggested. If you have any questions at any point generally about the tasks we're looking at, do post them in the chat, and we'll do our best to answer those as we go along. So Charlie, unless there's anything else in particular you'd like to say about robot monsters.
No, no, I was...
Right, okay, so let's go back to the feature. Here we are. The next task I'd like to share with you all is one called 100 Square Jigsaw. Now, it may be one that you've come across before from Enrich. If so, it would be really helpful if you didn't give anything away, if you offered some suggestions about how you could use this in the classroom. Think about the pedagogical side, please, rather than giving away the mathematics. So, Charlie, here we have another interactivity, and we've got a jigsaw, as the name suggests, of 100 square. You can see the pieces. Here's the square we're fitting into. I'd like you to have a little go. Where might you start, Charlie?
Can I just check? There are 4 different puzzles, and we're trying puzzle number 1, are we? We're trying puzzle number 1 to start with, yeah. Okay.
But you're right, there are 4 different ones. So here's number 1.
Okay. Okay, I'd go for the extremes, I think. I can see in the bottom right corner a jigsaw piece which has got the numbers 1, 2, 3, 4, and it seems to have the 1, 2, 3, 4 all in the straight line. So I would put them in the top left-hand corner and assume that the 100 square is going to start there and end with a 100. And I can see a 100 right at the top of all the jigsaw pieces. So I'd stick that at the bottom right and assume that this is going to go, okay, I think, okay. So I'm going to see whether I can find some pieces to go along here. So I've got there's a 5, 6, 7 next at the top, which could go butted up to the 1, 2, 3, 4.
Mm-hmm.
The 1, 2, 3, 4 might have to just nudge a little bit to the left.
Thank you.
Okay, and I'm going to see whether I can add anything to the bottom. Oh yes, there's a 94 and a 93. Oh, and okay. Okay, bottom left jigsaw pieces. I can see a 91 and a 92 that could go in the bottom left corner.
How do you know that that goes in the bottom left?
Because I can see that underneath the 4, you've got 14, 24, 34. Underneath the 6, there's a 16, 26, 36. So I think under the 1, I'm going to get 11, 21, 31, dot, 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 61, 71, 81, 91. And I think, yeah, so, okay, so I think I'm going to be able to do this. There's a jigsaw piece bottom left, which has got a 93 and a 94.
Yeah.
And there's also in the bottom right a jigsaw piece with 60, 70, 80, and 90 that could go right above the 100.
In the chat, David is also suggesting another approach is to identify horizontal connections, one more, one less, which you have been doing a little bit of there. And I think when we placed this piece here, perhaps there was some horizontal connecting going on as well, or were you still using your place value for the columns, Charlie, there?
No, I was thinking that as I go from left to right, I go up by ones.
Yeah, right. Yeah.
But yes, there's a 10, 20, 30, 40, 50 jigsaw that can go. Okay, I think this is going to.
I think we could. You could do this, Charlie, couldn't you? You could fit that in. I like the reasoning. I like that the patterns you were identifying and continuing. And I guess you were drawing on the knowledge of the traditional 1 to 100 square that you have anyway to complete it. Do you want to have a look at number 2?
Come on then. I like a challenge.
Okay. So here's number 2. Those of you participating, have a little look at these pieces and have a little think about where you would start. If you'd like to offer Charlie some tips, I'm sure Charlie wouldn't say no. Well observed, Esther. Yeah, you've Esther's noticed that there doesn't seem to be a 100.
And also, yes, initially I was going to think about putting the jigsaw piece with the 1, 2, 3 in the left. But if you did that, Liz, I think I'd get into trouble because I would end up with, so if you put that right in the top left,
yeah,
I think I'm going to have trouble filling that little space
below
the 1.
You'd need a piece that's just got 2 numbers on it, which I don't think we have we?
No.
No, nice reasoning. Yeah, okay.
But somebody spotted that there was a 0.
Yes,
so,
a couple of people have suggested you could start with 0.
And
okay, here we go.
The good thing about 0 is that jigsaw piece has got a straight vertical edge, so that's quite reassuring.
That is reassuring, isn't it? So are you suggesting, is 0 the smallest number?
I think so. I can't see any negative numbers.
Okay, so we'll pop that top left.
And so then that 1, 2, 3 piece could go next to it.
This one here, yeah. And that's also reassuring because that fits in very nicely, doesn't it?
And if I start with 0 and I have 100 squares, then the bit largest number is going to be 99. And I can see a 99 there at the bottom. So that, I imagine, is going to go right in that corner. And then I can imagine, yes, just like before, as we go to the right, we go up by 1s. As we go down,
Yeah.
we go up by tens. So in the top right-hand corner, I'm going to have a 9, and I can see a jigsaw piece there with an 8 and a 9, and that would fit nicely there.
Right. So again, we could go through the whole process now. It's interesting, isn't it, how we've established the boundaries, the lower boundary, the upper boundary, and once we've done that and we've looked at the patterns, the rest not quite drops out, but almost. Okay, thank you for your suggestions on the chat. So what about, should we have a quick look at number 3? And what do you notice about number 3? Could you post in the chat, what do you notice, and where would you start this time?
And I'm assuming that question is for everybody else rather than for me. Sorry,
Charlie, I didn't make that clear. Yes, please. Those of you participating, not Charlie, where would you start, and what do you notice this time?
No one's going to trust you anymore, Liz, because you seem to be trying to catch us out at every stage.
You are. I'm encouraging you to look carefully for patterns. That's what I'm encouraging you to do. But you're right. Yes, those of you have spotted that this is. Some of you have described it as being backwards. That it's going. We're counting down this time. It's in reverse. A couple of people have phrased it. So yes. I'm quite intrigued when people post in the chat, but they put a question mark at the end as if they're not totally sure. It feels safer, doesn't it, sometimes, expressing a comment in the form of a question. Sometimes we can be a bit anxious to be so demonstrative, to be so sure of ourselves. Okay.
But it's also good to encourage children to conjecture.
Yeah.
To say, on the evidence that I've looked at, it looks like this might be possible.
Right, so. Absolutely. Okay, so some of you are saying, Sarah's saying she's not feeling very assertive. That's fair enough, Sarah, that's fair enough. So some of you are saying, well, perhaps this time we need the highest number at the top. Fred has just suggested 100 top right. Where's the piece with the 100 in? Okay, this looks promising. So if 100 is the largest number, I guess we know in the 100 square, then 1 is going to be the smallest. So this time we could put the 1, I guess if we're going to top right as the largest, the smallest goes bottom left. How do we know that? How can I justify that positioning? I guess I can see here that along a row, we're going 1 bigger as we go right. This time, though, as we go up, we're going 10 bigger. So if I'm going 1 as I go right, is this going to work? Do you think? Let's see. Here's my 6, 7, 8, 9. I'm carrying on that pattern, going along the bottom. And then I just need my 10 here. I've lost the bit with 10. Oh, there it is. Okay. Yeah, this is looking promising, isn't it? We can see the counting up in tens in the columns. Yeah. Okay. As David says, yes, thank you, David. The vertical sequence and the horizontal sequences give the clues. That's what we're homing in on, isn't it? Final one, very quickly. What do you notice this time?
I do find myself looking for the smallest number and the biggest number to just see, to give me some idea about the range.
Yeah.
And then looking at the shape of the pieces that have got the smallest and the largest.
Yes, it's interesting because we haven't talked much about the shape of the pieces. You mentioned it earlier, Charlie, when you were just checking whether you could put the piece with the one on top left and realizing that the hole we had, there was no piece to fill that hole. And you might find that some children approach this task purely geometrically and fit the pieces together and don't pay attention at first to the numbers. I guess that's great. They're using a particular skill. I guess then a follow-up question that I would offer would be, well, how do you know that this placing is correct? What other information can you use to justify the positioning and draw their attention to the patterns in the numbers as well? Thank you for those of you who've commented in the chat. Yes, so this time we're going with 0 to 99, but we're starting 0 bottom left. I hope that's given you a little flavour of this task. We've sort of whizzed through that, but I'm sure you've got the idea. I wanted just to draw your attention again to
Liz, do you want to just put the 0 piece in the bottom left just to show, because it can't really go anywhere else. I mean, if you put it anywhere on the right, you'd end up with gaps that would never get filled. The only other place it could go is the top left, but then you'd need negative numbers to go below the 0. So you'd have some problems.
That's true. That's true.
Your light seems to have gone out.
I think it's just because I'm both Charlie and I are in different offices at our HQ in Cambridge today, and I think the lights, if you don't move around enough, they assume that I'm not here. So I'm just going to.
I think you need to get up and dance, Liz.
There we go.
And that's been called on camera.
Yeah, I should have turned my camera off, shouldn't I? That was foolish. Anyway, so where were we? Yes, thank you, Charlie, for just talking us through that. One of the things that I like about this task, in a similar way to Robot Monsters, is that you can approach it in multiple ways. And again, it's about encouraging children to articulate the way that they are thinking about it, to justify the placing of the piece. And if we go this time, one thing to say, this is actually a live task. Robot Monsters wasn't. This is a live task, which means that we're encouraging you to send in your children's solutions to this task. So rather than just giving us the answer, the completed grid, we'd really love you to communicate with us the order in which the children put the pieces in, but in particular, their reasoning at each stage. So do share those solutions with us when you try this out with your learners back at school. And you can send them to us by clicking on this button on the left here, submit a solution. You can upload images, for example, and if you'd like to give your children's name in school, then we will mention their names. Of course, we don't give ages or surnames. We look through them all and we publish a range of solutions. So the last date for sending these to us is Monday, the 11th of October. And then towards the end of the following week, we will publish a selection of solutions accompanying this task. Again, Charlie mentioned for Robot Monsters that you could print off a sheet and do this away from the computer should you wish. The same is true of 100 square jigsaw. You can print off the pieces and laminate them, for example, so you can use them again. I don't think there's anything else that I particularly want to flag up for the 100 square jigsaw. I think it's
maybe it's not necessary to say, but a little bit of advice is to label the backs of the jigsaw pieces with 1, 2, 3, or 4, because if they get mixed up, it would be a bit of a nightmare.
Absolutely, or do them on different coloured paper or something. Yes, good thinking, Charlie. Very practical, and a great way to really encourage learners to develop their understanding of the structure of number, the patterns in the 100 square, why we traditionally arrange the numbers in 100 square like that, the power of those patterns based on the place value system.
Normally when you have a problem, Liz, in the teacher's resources you have possible extension.
Yeah.
It seems to me a possible extension is you muddle up the pieces of all 4 jigsaws and then get them to sort them out. You muddle them up on purpose.
Slightly cruel thing to do, but that would be quite interesting. Okay, let's go back to the feature. And I think I'd really love to show you one more task in detail. Well, in a bit of detail anyway. This one follows on very nicely from what we've just done. And this one's called Coded 100 Square. This time, we have a 100 square, but we haven't written it using our numerical symbols that you're all familiar with. We've used some code, some different symbols which you won't be so familiar with. Our challenge is to arrange the jigsaw pieces into the 100 square, just as we did with the previous task. But this time we've got the challenge of decoding. So I wonder if you could have a little look at those pieces. And once again, you can probably guess my question. Where shall we start? What do you notice, and how might that help us start this task? Do post in the chat once you've had a chance to think. We've had 2 contrasting suggestions so far, which is interesting, but both draw on strategies we used for the previous task, I think. So we've got a number of different ways to proceed. Somebody has said we could look for the symbols which are only 1 digit, 1 symbol. Somebody else suggested that we look, is there one with 3 symbols? Is there one with 3 symbols? Suddenly got a bit of an echo. Others of you have suggested looking for a vertical pattern. Charlie, what would you do if it was you?
I think the piece on the jigsaw piece on the far left.
Yep.
Has a single
top
diamond,
left,
and it's got a vertical edge. And I can't, and there are other pieces with a single symbol, but I'm not sure they can go on the far left edge. You know, there's a single square and there's a single cross.
I see what you mean. Yes. So this is you again using your strategy about, am I leaving a gap which can't be filled?
So
okay.
I'd be tempted to put that in the top left-hand corner to start with.
Is there anything else, Charlie, that we could use on that piece that would help us justify its placing, as well as the fact that it's got that nice left-hand edge? Maybe not at the moment.
Yeah, I'm sort of thinking, because underneath it, it feels like you might be doing something completely different to what you've done so far, because till now every row differed by 10, but you've got 1 diamond and then you've got 2 diamonds. So I'm wondering, goodness, is Liz now going to have us coming down by 1? But then I expect 3 diamonds below that. Well, but maybe a cross is 2 and a 1. And then, okay. So that doesn't work. Perhaps it's too soon for me to be, tell you what, there's a piece on the bottom left that could slot next to the one that we've put.
Okay.
And I might be able
one
to.
Here.
Yes.
Okay.
So perhaps I can start. Yeah. So I think that can slot at the top, butt it up. Okay. Okay. So now I'm beginning to see a pattern here, because on the far left column, there seems to be diamonds on the right-hand side.
Yeah.
The second column seems to have these crosses on the right-hand side. The third column seems to have circles on the right-hand side. So this, okay, so this looks like it's place value. And so, yes, so okay. And every piece on the second row has got diamonds on the left hand. The next row has got crosses on the left hand. Okay, so I think we've got 1, and then underneath 11, and then underneath 21. So okay. At the top, 1, 2, 3, 4. And that black circle that you're pointing at now,
yes,
is the 4. And if we go down to the 5th row, we've got 41, 42, right. 43. Okay, right. Sorry, it took me a while, but...
No, nice reasoning though. Thank you for doing it all out loud. Some of you have pointed out in the chat that if we know that this larger symbol is the 1, as you pointed out, we might be able to find, that's another way of finding the 100. Another way of finding the 100, as was said near the beginning, might be, as Charly has reasoned through, that he's convinced himself and convinced us, I hope, certainly convinced me, that this system is based on place value. I think there was a comment right at the start when somebody said, oh, well, I think each symbol is a digit, or words to that effect. And Charly has just talked us through his rationale for agreeing with that actually we do have a place value system here. So if we have a place value system, I guess we would expect 100 to have 3 symbols. And I'm just looking around, and so this is the only square, the only piece I think which has got 3 symbols. And so we might
encouraging. And what's encouraging about that is just to the left of it, we expect to see 99. So now we know which symbol represents the 9.
Yeah.
And on the left-hand side, there's a jigsaw piece with a single square.
Aha, this one here.
And that can go the far right corner, because the one next to it then would be 10.
10.
That's also told us, confirmed, what the 0 is.
0 symbol is, exactly. And then we can see that 0 going down, can't we, down this column in exactly the same way that you'd identified in the previous columns.
But also on the far left column, we've got the 10s row, the 20s row, the 30s, the 40s. Yeah. The bottom one is going to be the 50s. Sorry.
Oh, sorry, this one, bottom one on here, yeah.
So that funny kind of H shape must be a 5. And we haven't got a 5 in the top row.
No.
But we can now
see it.
It's in the bottom right. So that's giving us the 5 and the 6.
Yeah.
So we'll also be able to work out the 60s.
Yeah. Where I can't see them immediately.
So we want.
Oh, here.
Yes.
Here they are. So this has got to go.
Yes, and that's going to give us the 70s and the 80s.
Where's this going to go?
Far left.
Thank you, because it's got the 1s. We can recognize the 1 symbol. And here's the 6, the 60. Yeah, and so we can continue.
Yeah, and below that, we've got sort of 2 arrows.
Yes, so this must be
a very masculine male sign. That is what we're looking for the top row then.
Exactly. So we could go on. You hopefully get the the idea. Thank you very much for watching and suggesting your thoughts. It sometimes can be quite frustrating, can't it, when you're watching somebody do it their way and you have other ways. So thank you for bearing with us. We hope that that's helped you appreciate the sheer number of ways you could approach this task. One thing that I'd like to mention, which Charlie, you mentioned to me this only earlier this week, I think, is this. John Mason, who writes, who's a very eminent mathematics education researcher. He writes a lot about, particularly about problem-solving mathematical thinking in maths education. Charlie was telling me, he was reminding me about an approach that John uses, where if he's looking at a new problem, he thinks about what he's going to do to start the problem, how he might approach it, but he immediately tries to stop himself and think about an alternative way of starting, to try to force himself to think about those other possibilities and other avenues. And I've been in sessions where John has done that, and it can be quite jarring. It can be really difficult as a learner to make yourself do that, but I think very valuable as well. So you don't always go for the same things. You become more fluent in different approaches, I think, and you value other approaches. So we're coming towards the end of our time here. I think we've given you a taster of 3 of the tasks in the feature. I'd like to just go back to the feature itself very quickly. You can see that there are many other tasks there for you to explore, for you to have a go at with your learners. And we would encourage you, please, if you do work on them with your learners, to send your solutions to those which are live. You can see the little grey live symbols for those that we are receiving solutions to at the moment. So do get in touch. Charlie, is there anything that you'd like me to add about any of those tasks or the feature in general before we look at some more general?
Yeah, I think you've said everything that needed saying. Okay,
great. So let's just go back then. I'm going to stop sharing. I've lost my mouse. There we go. I'm going to stop sharing the Enrich site, and instead I'm going to go to the PowerPoint, and there are a few things that we'd just like to draw your attention to before we say goodbye. Sorry, I'm almost there. Just about to share my screen. There we go, and that's the one I want. Okay. We've really enjoyed working with you this afternoon, and thank you very much for your posts in the chat, because it really makes our life a lot easier, knowing that you're having those conversations as much as we can have conversations in this medium. We do hope to run further webinars like this. We mentioned that the generous funding from Trinity College. If you'd like to be kept informed of future opportunities, do follow us on Twitter and or sign up to our email newsletter if you don't already receive it. We mentioned the feature that we've looked at today, but this is another link that I'd like to draw to your attention. Here you will find on our primary curriculum page, which is the sort of the portal for all things curriculum related on the Enrich site from a primary practitioner's point of view. We've got our mapping documents, which take Enrich tasks that are linked to specific curriculum objectives. You'll find that on that page as well, and different ways to search the task if curriculum is your driving force. So do take a look at that if you don't already know about it. If you wanted to look at other features that we've already published, then do have a look at that link. Incidentally, these 2 links you can find from the primary teacher homepage as well. We'd love your feedback on today so that we can make sure we're doing the kind of things in these webinars that are useful to you in the classroom. So do please make sure you give us your feedback. There's the link, and I know that Ems has already been very efficient and posted it in the chat. The link above, which I just skipped over, sorry, Enrich Live SEP 2021, is the page on which the recording of today will go. So you will get notified of that in an email from Eventbrite later today as well. I think then all that is left for me to say is thank you very much. And we do hope that we'll see you again sometime on a future date. Thank you.